to the lecture series of switching theory and logic design. In this lecture, we will see Mealy to Moore conversion and Moore to Mealy conversion. That is, we will see two conversions from Mealy to Moore, Moore to Mealy in this class. First, we will see Mealy to Moore conversion. That means the given problem is there in Mealy machine model. Now we have to identify the Moore machine model. Then analyze what is the Mealy machine. The Mealy machine is representing, the first column is present state, the next column is next states and output based on the input combination. So see here, we will see one example here. So before going to that example, first see here, to convert Moore machine to Mealy machine, state output symbols are distributed into symbol paths that we will see later. Coming here, we are concentrating on Mealy to Moore conversion, but while converting the Mealy machine to Moore machine, we will create a separate state for every new output symbol, and according to incoming and outgoing edges are distributed. That is, in the Mealy machine we have some 4 states or 3 states or 5 states. When you are converting this Mealy machine into Moore machine, we are creating new states. For example, in Mealy table we have 3 states, then in Moore table we have more than 3, that may be 4 states, 5 states or 6 states may be available. That is depends upon the output conditions. Okay, that we will see with 3 steps. So coming to that, into the overall process, we have 3 steps for converting Mealy machine to Moore machine. Step 1, for each state QI, calculate the number of different outputs that are available in the transition table of the Mealy machine. In the Mealy machine, we have the next state outputs for x is equal to 0, x is equal to 1. For example, we have Q0 present state, Q1 second state, Q2 second state, Q3 next state. Like that we are defining different types of states. For Q0 is the present state, next state output x is equal to 0, x is equal to 1, you have to check. If both outputs are same, no problem. If both outputs are not same, you have to create a new state for the present state. That we will see with an example. Step 2, copy the state QI if all the outputs of QI are the same. If the state outputs are same, then same copy this present state and shift it to the Moore table, no problem. But it has different outputs, then you have to split that state into 2 parts and you have to write new states in your Moore table. Step 3, if the output of the initial state is 0, insert a new initial state at the starting which gives 1 output. That is, here we have to write 0 output state, 1 output state. That we will see with this example. So here, one transition table, one state transition table I have taken here. Now I will do the explanation for this one. So, present state. This is a Mealy given table. Present state. Next state, comma output when x is equal to 0. Next state, comma output when x is equal to 1. So this is about Mealy machine table. Now we have to convert this Mealy machine table into next Moore machine table. For that, first step. First, find out those states which have more than 1 outputs associated with them. Right. So how many outputs have 2 different outputs? How many states have only single output? So see here, for Q0 we have only 1 output, that is 0. For Q0 we have only 1 0 output. We have 0 output and 0 output. Okay, so both the next states of Q0 has 0 0 output. There is no necessity of partitioning here. There is no necessity of doing partition. So see here, Q1 next state outputs are 0, 1. 2 different outputs are available. For Q2, 1, 0. Next state outputs are 1, 0. 2 different outputs are available. For this one and this one, 2 different outputs are available. So for that reason, you have to make the partitions for Q1 and Q2 system. Q1 and Q2 states. Q0, there is no necessity of doing the partition. Okay, Q1 and Q2 are the states which have both output 0 and 1 associated with them. For these two states have zeros and ones. Two outputs are available, but for Q0 only 0 output is available. For Q1 0, 1 outputs are available. For Q2 1, 0 outputs are available. Right? So if only one output is available, no problem. If two different outputs are available, then you have to split this state into new state. For example, here you have Q1. This Q1 you have to shift into Q1 0 and Q1 1. Where Q1 0 is representing with 0 output, where Q1 1 is representing with 1 output. So the last two digits, this 0 and 1 is representing their corresponding outputs. If the output is 0, then new state is Q1 0. If the output is 1, then new state is Q1 1. These are the two new states are available. Now coming to here, create two states for these two states. So for each state you have to create two states. We have taken two states. Totally you will get 2 to 4 states. 4 new states we are going to write in the Mealy table. So for Q1, 2 states will be available. One is Q1 0 and another one is Q1 1. Where Q1 0 state with output 0, where Q1 1 state with output 1. Similarly, for Q2 also 2 states are available. Q2 0 and Q2 1. These are the new states. Now coming to here, so see carefully, this Q1 state I have divided into, so first see here, Q0 state I have written directly. Why? Because there is no change in the output. For Q1 state, so I have divided into two parts, that is Q1 0, Q1 1. Where Q1 0 with 0 output, where Q1 1 with 1 output. That is for Q1 0, here output is 0, where Q1 1 output is 1. Where Q2 0 output is 0, where Q2 1 output is 1. And Q0, both outputs are 0. Directly you can write how the output is equal to 0. Over, completed. Right. Next step. So, next, whatever the next states are available for x is equal to 0, x is equal to 1, write down the states. But when you are writing, so the Q1, actually this Q1 we are divided into Q1 0, Q1 1. Now, Q1 is not available. Now Q1 is not available. Then what is the value I have to write here? What is the value I have to write here? So see here, Q1, here Q1 output is available with Q1 state is available with 0 output. Now you have to write down by combining these two. That is Q1 output with 0. Q1 output, Q1 is the next state and output is 0. Then you have to write down here Q1 0. That is Q1 0. Here Q2 next state and output is 0. Then you have to write down Q2 0. Q2 0 you have to write here. That is our next state. So see here Q1 Q2, that is Q1 0, Q2 0 and 0 output we have written here. Right. Next, coming to that Q1 0. So whatever it may be, Q1 0 or Q1 1, next state is Q1 with output 0. Now you have to write down here Q1 0. Here you have to write down Q1 0 for these two Q1 states. And next state is Q2 and output is 1. Now write down here Q2 1 and Q2 1. Right? Q2 1 and Q2 1. I said that already. Q1 0 with 0 output, Q1 1 with 1 output. That is our next step. So that is our next step. Next, Q2 also. Similarly, you have to do the same operation for Q2. Q2 is the present state. Next state is Q1 with output 1. Then you have to write on here Q1 1. And Q2 is the next state and 0 output. That is Q2 0. You have to write on Q2 0. Now this is Q1 1 and this is Q2 0. Q2 state with 0 output. Now write on here 0. Q2 state with 1 output, Q2 1. That is we have written here. So this is the finalized output behavior. This is the finalized output behavior. So see here, these are the present states. These are the next states. These are the outputs. These are the Q0 is the old state we have taken from the Mealy table, and Q10, Q11 we have taken the previous state table and based on the Q1, and we have taken two new states based on Q1. Based on Q2 we have written two new states, that is Q20, Q21, and outputs we have written. So this is the finalized step of the Mealy machine to Mealy machine conversion. Okay, now we have converted Mealy machine into the Mealy machine. It is very simple process, no doubt clear. Okay, thank you.